Another thing we can do with text documents is to look at word clouds. Word clouds are not really rocket science. I mean, all you do is you look at the text, you look at the words in the text, you count their frequency, and then you throw them out in a little cloud where each word is sized based relative to the frequency, its frequency in the text. So they're not really rocket science, but they're very useful because you can very quickly see what the text is saying, and where you get the top few words and it tells you, oh yeah, that's what this thing is all about. So let's take a look at that. And to do that, we also need to install word cloud, which I should probably do. So it's cell above, and we install word cloud, pip install word cloud. Okay, so once we got word cloud installed, what we'll do is we'll take all our snippets and combine them into one string, and then generate a word cloud using the words in the string just to see what do they say about restaurants in the neighborhood that we have around here. And so let's do that. So all snippets are these ones. So what you want to do essentially is run through this here and extract the item in for each tuple in the third location, location 2, right? So we want to run through this list of snippets and extract whatever is in location 2 of each tuple, and then concatenate them all into one giant string. So that should be easy. So we'll do that here. We do this, and we get a nice long string that does all our stuff here. And now we want to set up a word cloud for this. The word cloud is pretty easy to set up. All we do is we import from word cloud, we import word cloud and stop words. Stop words is a set of words that, and this we'll use these stop words in other places too, which are very commonly used, like off and the and at and in and all that kind of stuff. So we eliminate all those words. And then we are going to display it. So we want to import matplotlib as well. So it uses that. And make sure it's inline. Again, we want to display it in our thing here. And then we create the word cloud. We say word cloud equals word cloud, which is the object we've imported over here. Give it the stop words. So you can give any list, any set for the stop words over here. You can create your own stop words if you like. Create a background color, white, and that's what is there. A width and a height, and so to make it bigger or smaller. And then you generate it, okay? And you generate it using, you're generating the word cloud here using the text that we created over here. That's the variable that we are passing to it. And then we use the show, matplotlib show image show button, because this is creating an image. So we want to image, IM show is image show, and we say show this word cloud, right? That's this one. And then so the axis is off, it doesn't matter, we don't need axes for these, we don't need X and Y, and then show it, right? So this is what it does here. So it says pretty, French, food, though, place, restaurant, blah blah, right? So but this is all the restaurants. So what we would like to do, of course, is compare the restaurants and see how they work together. So in our data set that you should have downloaded, there are 4 sets of reviews. A review for community, and that is in a location data/community, and there are I think 15 files per review, so 15 reviews. And then Le Monde is in data/Le Monde, and Heights is in data/Heights, and Amigos is in data/Amigos. These are 4 different restaurants in this neighborhood. Community is a sort of local American food restaurant which focuses on local foods. Le Monde is like a sort of Frenchish kind of restaurant. Heights is Tex-Mex kind of restaurants, and Amigo is also sort of mixed Mexican restaurant. None of them are pure Mexican, but they are kind of Mexican. So what we set up the thing here, we're going to use NLTK for this, and from nltk.corpus, the library, we import this plain text corpus reader. Plain text corpus reader is a way of reading data into as a corpus into your application here. So what it does is it essentially takes a file. Well, if I look at our set of files here, if we go here, data, if we go to data community, it has all these files here, right? So it takes these files and it can load them into as separate files, and each of them as separate documents into your application, and that set of documents is what's called a corpus in this in the lexicon that we use here. And the nice thing is then that you can actually sort them. So here we have community 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could sort them by the names of these things, and we'll use that for this. It doesn't matter, but for the inaugural text we'll use that. If you actually, they're right here. You can see that the inaugural texts are numbered by year, so we can always assume, we know that 1941 comes before 1953, right? 1953 comes before 1993. So these become sorted, and we can use that fact that they are in a certain sequence when we're doing analysis. Not so much for community and all that. We don't really care. Plus, it's not going to work very well because they're not really, sortable. They're text. So 1, 0 is going to come before 2, for example, which is not what we want. Oh, sorry, that is what we want. That is what you want, right? 1, 1, 0, 1, 1. Yeah, that is actually what we want. So it'll actually work. All right. So what we do is we set up the root directory where we are going to get the files from. So we have a root for community, and we set up the format of the files. Like your directory might contain many other files. The files we are looking for are community.star for community. We could put all of them in one location, and then we have community files, a community.star, lemon files, a lemon.star, etc., etc. But we can work with that. And then we set up our corpuses in our application by creating this plain text corpus reader, which has the root. It needs to know the root, where the files are located, and how to identify the files in that folder, right? So this could be anywhere. It doesn't have to be in data community. It could be anywhere. You want to give the complete path to this. In our case, we don't have the complete path, but we are giving a relative path because data, the directory data, is in the same location as where our current text mining .ipynb file is. So we do all that stuff, and we can look at the file IDs of these things, and we see that they correspond to the file IDs there. So what the plain text corpus reader is doing is it's storing these things with their file IDs in a sort of a internal directory structure, so to speak. And you can access each one separately if you want to, or you can access all the data. So you can say Amigos data, which is our variable that where we put this one here, right? This is Amigos data, where we can use the raw function to extract all the stuff in this here. So this is the entire text of all the reviews, and these reviews were actually just cut and paste I just cut and pasted them from Yelp. So that's all they are there. So now I'm going to just modify comparative analyzer so that it tells us where the restaurant name is. It's a very simple one. You can take a look at it, and then we run it, and we get this over here now. This is our all snippets. So okay, I run it with restaurant data. So it's restaurant data. I'm going to give it the tuples. I'm going to give the name of the restaurant. So essentially, I've taken out the ID field from there. That's what I've done, right? So we have community and community data raw, lemon data raw, heights data raw, and amigo data raw. So I'm taking all the text of those 15 reviews, and we're going to look at compare the emotions on those things there. So for these 4, we get this over here. Look, it looks very different now. The 0.04 for community fear has vanished. The reason being that the snippet is not included in the reviews. The snippet is what Yelp is providing me right now. The reviews are what I had downloaded earlier. So that snippet is not there, and so we are not seeing any fear in community right now. We are seeing a bit of fear in Amigos. So again, bear in mind that these numbers, though they look small, are actually quite meaningful because there's a lot of other stuff that doesn't have emotion attached to it in the reviews. So what this tells us is that community has the highest positive rating, 0.05. It also, they all are equally negative, and equal trust inspiration, but for some reason Amigos inspires some fear. And both community and Amigos have at least something that is disgusting about them. Heights has the highest anticipation, and this actually makes sense to me because it's a very nice bar and people like to go there and drink. There's some sadness, I don't know where that comes from, associated with community, heights, and Amigos. And there's also surprise associated with all of them. So that's kind of nice, right? So we can do this kind of stuff here. So that's this thing. And again, just bear in mind that you don't have to use fear, trust, negative, positive, joy. If you're working in a domain, you can actually attach your own words and use those instead of using these, and then use the same procedure to figure out what the documents are trying to tell you.